So, before I talk about the carbon landscape, I hope you'll just bear with me for a minute. I want to go back a step and talk to you about the first time I realised that the projects I was involved in were doing more environmental damage than good. Because for me it really set the baseline for the carbon landscape moving forward. And so Liam mentioned that we met in Whakatane. My second job after Whakatane was Jordan. So I got a job in Jordan, didn't know much about Jordan, actually had to go home, find a map, work out where Jordan was. I accepted the job without knowing really where it was. This is all pre sort of Google days. And decided to go and have an adventure in the desert. And there were old ruins and a different culture and a different language and a different food, and it was an amazing experience. And as a young landscape architect at the time, I was really excited and energised to have this incredible opportunity. And so my job was to vegetate the desert. Now, I was working on 5 hotels, and I was a project manager trying to deal with the landscape issues for these series of hotels. One of them just happened to be down at the Dead Sea. Now, the Dead Sea is about 500-600 metres below sea level, right, which is why they call it the Dead Sea. Very, very high evaporation. The salinity level of the Dead Sea is about 27% salinity. Seawater is around 3 or 4% salinity, so incredible sort of environment. And my job was to help manage not only the hard landscape but the soft landscape, which involved planting over 300,000 trees in the desert. So I took that on, and I come to realise as we were going through that process that actually maybe it wasn't a particularly sustainable idea, because it hadn't rained for more than 8 years. There was no water. And here I was planting 300,000 trees on one single site that went through 80 cubic metres of water a day to feed these trees and these plants in a place where that naturally hadn't occurred or does not occur at all. So not only did we have swimming pools and spas, we had this lush vegetation that was completely out of landscape character and was consuming water, keeping in mind that the local villages surrounding this area didn't have reticulated water. And it was a first time in my professional career that I realised that I was involved in something that was doing more environmental damage than good. And the problem with success is that it was a successful design. The pools and the resort and the amenity were successful. And with success comes tourism, and with success comes duplication. And we were the first hotel. But these hotels keep growing and growing and growing. And the environmental damage kept getting cutted and pasted and repeated and repeated and repeated. And at that point I realised that landscape architecture wasn't just about aesthetics and circulation and plants and water. It had a much greater impact, and that you could actually be on the wrong side of the conversation from an environmental perspective. In the next 10 years, I ended up working in New York, in India, in Palestine, and I had a series of learnings from those places too. The Jordanian one on the Dead Sea was the most negative from an environmental perspective, but in Palestine I learned about the power of access to land, and through good land design and management you could bring economic growth to an area. In India I learned about the power of water and how that affected education, and how that could really improve the lifestyle and quality of life and education for a group of people. In New York I learned about what happens when the free market demands a very high level of sustainability and how the design industry reacts to that. And so there had been quite a learning opportunity over the last 10 years through a variety of locations that I'd worked. And so I came back to New Zealand and I wrote articles about it. And it was interesting. This isn't about 2004. I'm explaining, the sort of the ups and downs of landscape architecture and the ins and outs of it. And then I mentioned that there's a carbon footprint to what we do. But it wasn't necessarily particularly well received by all the industry. And I started getting letters about it. And one of the letters said to me, look, there really isn't a carbon footprint to what we do. It's unlikely. But even if there was, surely all the plants we plant offset the carbon impact of what we do. And I thought that was an interesting idea. I don't think it was true, but I thought it was an interesting idea. And I get the idea. If you look at landscape architects, or, and as an analogy actually just for open space. When you look at open space is normally designed at a high level of ecological consideration. We have low impact stormwater design now. We consider cultural and heritage values now. So you look at open space and you see lots of positive values. So it's hard to look at something with such high positive values and imagine that there could be any negative connotations sitting below that surface. But the question I wanted to look at is what happens if you look at those open spaces and what we do as a design profession and added climate change impacts or the carbon footprint of what we do into our equation, how would we stack up? And if you consider that there is a carbon impact to what we do, then what happens when we redesign every 20 years? How does that affect the equation? So this was all spurred on by that question about, is there a carbon cost to what we do, and if so, can we mitigate it with the natural environment? So for the next 10 years, and I wasn't planning to do the next 10 years, but this is what happened. This is the first thing I did, is I looked at what the carbon footprint of a landscape architect is. The next issue I looked at was, if there is a carbon footprint, at what stages of the design process and building process and management process does carbon sit? Then I looked at the cost of urban renewal, and then finally I looked at the tools available for us to control the carbon footprint of what we do. Now, theoretically, in 2018 I shouldn't really have to put this slide up. And it just is spelling out from the UNEP, so the UN Environmental Protection Agency, who do significant international research on climate change. And their point is that there is no doubt that it's happening. That it has been happening since the beginning of the Industrial Revolution, and it is humankind driven, and it matches population growth and economic growth. I still meet planning and design professionals, even in the last 7 days, who still do not believe climate change is real, and is not human-driven. Now, I tend to lean more towards NASA's research and the UN's research than pop culture. And so if I was to go with peer-reviewed scientific evidence, it certainly suggests that not only is climate change happening, but it's happening at an alarming rate, and that it is certainly a consideration. Now, it has become, in the last 6 months, a much more popular topic, certainly since the Zero Carbon Act came out, where they're looking at government requirements to start considering the mitigating or reduction of their carbon footprints in the way that they manage land and buildings and resources and procurement, and also transparently showing this. Well, what's interesting about that is actually local government has always had a legislative requirement to show this information for the last several decades, but it hasn't really been monitored. And I think what's different now with the Zero Carbon Act bill being currently tested is that there's a suggestion that there's monitoring involved. And so all of a sudden what I'm seeing is councils having much more open conversations about this, and I see the consultants quickly tooling up to be able to deal with this conversation. So as much as I've been talking about this for 14 years, for the last 6 months has been the time where I've seen the most movement on this issue. And when you talk to councils about this, you say to them, all right, so they understand they've got to reduce their carbon footprint. Where do you think your carbon footprint sits? And they say, well, there's the energy systems within our buildings. Possibly they'll talk about how the building's made, but they can't mitigate that now. But certainly the energy systems within their buildings, their procurement policies, their waste management. They'll talk about their vehicle fleets and how the cost of the vehicle fleets. And if you ask them about reducing the community's carbon footprint, they'll often fall into cycleways, so reduce vehicle movements for public movement, to reduce carbon footprint. I'm yet to hear a council talk about the carbon cost of the open space network. And I kind of get that, because it's hard to look at a green park and think that there's any carbon tied up in it. But if you look at the footprints of a council building and all the other buildings they own, all the amenities, all the halls and sports facilities that they own, it pales in comparison to the amount of land that they manage. So by sheer volume, the bigger carbon footprint sits in the landscape, not in their infrastructure. Now, to kind of illustrate this idea, to show that there is a carbon footprint to what we do, I ended up looking at my personal carbon footprint. So I'm a landscape architect. I design open spaces. So by looking at what my carbon footprint is for the spaces I've designed, you can start looking at what an average carbon footprint would be for my industry. Now, at the time when we did these calculations, we sat down for a week with a student. And in the old days, we'd have drawers full of plans, and you would slap the plans down on the table and you would go through them. So we did that. We pulled out all my old plans and we started looking at the projects that I've been involved in and calculating out the material use that I had specified as a designer. Now, I'd like to say I've been a pretty average landscape architect. And I'd worked for council for a portion of that time, so I'd done playgrounds, car parks, street tree planting. Nothing too exciting, so no vineyard quarters, no massive town centre design, so arguably I was generally a pretty carbon light sort of guy, if there is such a thing from a designer's perspective. So we start this conversation with the preface that I'd never been involved in a lot of very carbon heavy projects. Also, it's really hard to work out the carbon footprint of a project. So instead of working out where all the nuts and bolts went, and I just picked the 4 major materials that I had specified on my plans. So concrete, steel, asphalt and timber. I also found a carbon calculator for office hours, so I threw that number in, which is not a particularly high number, and transportation. And so I ended up with a carbon footprint of almost 16,000 tonnes. So what? I had really no idea what 16,000 tonnes meant. Kind of sounded maybe big, but I didn't really have much to make a comparison of. But I also had an ace up the sleeve. I've been involved in really large reforestation projects for a decade. I'd done a lot of reforestation projects in Whakatane, and then when I went to India, I was involved in reforestation projects there to deal with the water system. And I knew, because in India I'd set up the nursery that grew on the trees, so I knew how many trees I had specified, and in Whakatane I do the watering and the planting as well. So I knew basically how many trees I had specified. Now theoretically there were a whole lot of people involved in that exercise. I pushed them off to one side. I took all the carbon credits for those trees purely for myself. All right? Which is a bit unfair, but you know, I wanted to look on the right side of this conversation. So, if you take my carbon footprint of just under 16,000 tonnes over that 14-year period, and you take off the trees only come to just 500 tonnes. Right? That still meant I was 14,500 tonnes in debt, even with the offset of trees, which fundamentally answered that question. Do we have a carbon footprint? Hell yes. Can you offset it with your planting? No. So, to be honest, when I started that, I never expected that outcome. I never thought that there would be that much of an imbalance in the cost of what I specify versus what I can offset. So then I wondered, if that's the case for me, what happens if you multiply that out by the industry? Well, there are 596 registered landscape architects currently in New Zealand. The average of my carbon footprint was 1,100 tonnes per year. All right, so what's the annual cost of the NZILA's registered landscape architects? Keep in mind that not all open spaces are created by registered landscape architects, so this will be a conservatively low number. So if you multiply that out, it meant that NZILA's carbon footprint for open space development in the course of a year was 655,000 tonnes of carbon. Well, how do you visualise that? Well, I have a cousin who's in forestry, so I had to talk to him. And there is Canadian research on how much carbon a tree sequesters within a year. And you would need to plant 71 almost 71.5 million trees every year to offset the design work of 596 landscape architects. Now I was thinking about that, thinking about how big my backyard is, thinking that's probably not going to be able to get those in my backyard. So I wondered how much space I needed to offset that, to plant those trees to offset that carbon cost. And you need about 238,000 hectares of land to offset the carbon footprint of the environment. All right? Again, that was kind of hard to get my head around as well. So I was like, well, how much is that? Well, it's about twice the size of Auckland. So in an area twice the size of Auckland, you would have to plant every single year to offset the open space design industry's carbon footprint. And that's every year. Now, I was recently in Texas. They asked me to come down and have this conversation to the American Society of Landscape Architects. So I threw their numbers in there as well. And they had there's a few more of them. And they come up with they needed 354,000 hectares of land, which was 5 times bigger than Austin. So I was presenting in Austin, so I used Austin as the example. So it was 5 times bigger than Austin, and that went from Austin all the way over to Fredericksburg. They would have to plant a forest that size to offset their carbon footprint each year. But like I said, it's every single year that you would have to do that to offset it. And that is based on an average carbon footprint. What happens if you picked up a client who was maybe a little grumpy with a neighbour and wanted to build a wall that was maybe, 2,000 miles long and 12 metres high? If you were to calculate out the amount of concrete to go into that wall alone, you would have to plant a forest 1.6 million hectares in size. Now, as I pointed out to them at the time, because I was in Texas and I like to say I did manage to walk out of the room alive, I pointed out to them that they would need to plant a forest about the size, a bit bigger than Connecticut. Now, when you make these suggestions to Texans, it's good to point out that actually they can plant that within Texas. Texas is quite a big state. Otherwise, obviously, the concern would be they would invade Connecticut to plant a forest. So they could do it there, but that only considered the concrete. They did not consider the steel or the implementation costs. The point is this. The carbon cost of what we do as an industry cannot be offset by the natural environment. The natural environment is really good at sequestering carbon. Salt marshes are, trees are, grass, meadows. There are lots of elements that sequester carbon in our environment, and it's good at it. But it can't do it at the rate in which we produce carbon. There's such an imbalance that we can't match it. Now, I read an article the other day, just before I came from Texas to here, and they were saying that we should plant 1 billion trees. I like that. I support planting 1 billion trees. It's okay, it's good. But it would only offset 14 years of our carbon footprint from the NZLA's perspective. And again, it talks about, that's not offsetting anything but the design industry. That's not talking about any other industry. So 1 billion trees are great, and we should plant 1 billion trees. But not only would you need a massive land area, it's not a massive offset. Alright, so it was a bigger issue than I thought within our industry. I hadn't understood the scale of it. Keep in mind the numbers I've talked about are conservatively low. Right? They should be much bigger than I'm showing you, so they are conservatively low. I was like, oh, alright, well then, where do the costs sit within our industry? How do we work out where they sit so we can work out how to manage them? Well, so I broke down what I do into, say, 4 stages. The design component, the implementation component, the ongoing management or maintenance of open spaces, and then looking at the urban renewal process. I looked at the carbon cost at each one of those junctures and thought about how you might manage. Now, let's talk about design. So within the design component of open space design, it's not very big. That's not where our carbon footprint sits. Now, we did the Coburg Initiative in Melbourne, what I did do is ran a carbon timesheet for the design team. And it was an international design team, and it was all spread out throughout Australia. And we made them keep track of their hours in the office, their modes of transportation, and the mileage they did. So whether it was flights or cars or bus or whatever. And the reality was, there wasn't much of a cost. It's not where our carbon sits. Now, it's easy for us to manage our office spaces to reduce our carbon footprint, and we should all just do that as of just good logical sense. But that's not where we spend our carbon costs. It's at the implementation and material stages where our highest costs sit. And basically it sits in a number of locations within implementation of materials. And the first one obviously is materials. So the biggest portion of our carbon footprint sits within the materials that we specify. So as a designer, if I specify one material over another, it will have a different carbon footprint depending on what material I select. And in general, a general thumbnail way of understanding this is that really the less the material is manufactured and manipulated and changed, the lower the carbon footprint is. So the lower and closer it is to the earth, and the less refined it is, on odds that the carbon footprint's lower. So you start off with, so you can imagine crushed aggregates, for example, have a lower carbon footprint than steel. Right? That's not rocket science, it's pretty straightforward. All right? So all these things sit within a continuum of carbon, and the first thing sits within the materials. That's the first decisions we make when we make design decisions. Now the way to understand that, and it is internationally accepted way to understand it, is an LCA, life cycle assessment of the material, where it's a scientific assessment based on an equation that looks at how a material is harvested and manufactured and refined and delivered. And that gives you a number. And that's called an LCA number. And it's really good because it means that if everyone has an LCA number for a material, then a designer can look at those materials and understand the cost of each material, almost like picking an object off the supermarket shelf. You start having enough information to make informed decisions. The other really useful thing about an LCA is that it gives you an idea about where within that material the carbon sits. So for example, one of the letters I got back in the past was saying, well, concrete, how could concrete have an embodied energy because it's harvested out of the rivers, and Canterbury it is. It's batched locally, it doesn't travel far from the place it's batched to the place we use it, so where's the carbon footprint? And that's where the LCA is useful, because what it tells you is it's tied up in cement. It's the cost of Portland cement is where the carbon footprint sits for cement. Now, for other products like timber or steel, the carbon footprint sits in different locations, but just for cement it sits within Portland cement. But when we talk about the impact, the carbon impact, we can't forget that there's a bunch of other pollutions tied up with the way we specify materials. And so, for example, if I use an accelerant in concrete, if I use a retardant in concrete, if I want an exposed aggregate surface, there's an environmental footprint to that as well. And this is where, instead of focusing on sort of an aesthetic outcome of a material, but looking at performance outcomes of a material, this becomes a very useful tool. And interestingly, because we all use materials, and materials will continue to always be used, but it's unfair to say that the carbon footprint only sits with materials. Actually, plants have a carbon footprint, and I know that everyone would think a carbon footprint in a positive way, but it's interesting that actually not all plants are on the right side of the carbon compensation. So I learned recently that the way annuals are grown are really interesting. It's really high intensity energy systems are used to grow them on. They're grown on very fast. They're very heavily chemically manipulated. Your marigold is like the battery chickens of the plant world. They have massive carbon footprints, and they had a lot of toxicity into the soil. So even things that seem benign and green and actually kind of pretty have a carbon footprint. Now once you accept that there's a carbon footprint to the surface we put on the ground, how we put that surface on the ground also has a carbon footprint. So the way we implement a project, the way we build it, has its own carbon footprint as well. And it's one of those parts of the research that's kind of missing. The architects have looked into this a little bit. They've looked into how they build a building and how they can build a building to reduce the carbon footprint of the construction process plus the wastage. But from what I've read to date, it's really been around a residential scale, not around a large building scale. And it hasn't really been applied to open space, urban design and landscape architecture. And in many ways, some of my regrets, if I've been a bit faster, is when I had been doing urban design and the most recent urban design projects that were built, I wish I'd ran a carbon timesheet for those implementation projects. If I had made it as part of the tender requirement and the construction requirement for the contractor to keep track of what plant he used and how he did it, would have provided really useful information to understand how these things are built and where we can potentially reduce the carbon impact. But there's certainly, without a doubt, a reasonably heavy carbon impact to how we build it. We just don't have a lot of information on it. Now it's interesting because you can't look at a material and say there's a carbon impact to that material without understanding how it's built and what happens below the ground. And so a few years ago we did a very in-depth report that was written with a university or co-written with a university and peer-reviewed, looking at a 10 square metre surface area and the amount of carbon, energy and financial costs, which is always a part of the decision-making process, that it would take to make, say, 10 metres of square metres of steel decking or concrete or timber, so that we could start making informed decisions because you would have the entire picture rather than just the surface picture. You would understand what was happening below the ground. And it's kind of interesting because some of the carbon costs are high, but the energy costs don't always match. And this is where LCAs are quite good, because they will show you the entire equation about how you get to those numbers, but it's not always what you think it is. So once you understand that there's a cost to the surface, what happens below the ground becomes really important too, and it starts making you wonder about some of the things that we traditionally design, certainly in the last decade, into landscapes, such as rain gardens, that might not be as green as they look. So the old classic rain garden is, like an amenity garden. It just sits maybe 6 inches or maybe 100 mils below the paving surface. And that's what you see. You see planting and paving. What you don't see is the significant amount of substructure that goes below that rain garden, including the concrete and the steel, and the reinforcing and the pipe works and the filtering and the special soil materials that make the rain garden work. And each one of those components has carbon footprint. Of course, that information gets covered by soil or plants. And so it's not always transparent. So if you look at rain gardens, for example, I really support rain gardens, and they make sense from a carbon landscape perspective, paying the carbon debt of a rain garden, as long as you use a material that best fits design with a rain garden. So something like in situ concrete, which is capable of holding itself up and holding an edge so that the water can flow across and into a rain garden, comes with a carbon footprint that may make sense. Particularly if it deals with, say, 80 to 90 or 100% of the stormwater in that area goes into that rain garden, that makes sense, right? It doesn't make sense if there's a traditional stormwater system, pretty close, that's also taking away some of the water. It needs to be, to pay the carbon cost of the rain garden, it really needs to be doing most of the work. So, when you're looking at a rain garden, something in this photo here, in situ concrete, holding its own edge up and supporting itself makes sense. It starts getting really expensive when you start pouring whole streets of concrete and punching holes through that streets of concrete just to plant rain gardens. So instead of being discrete areas that uses, for example, the durability of concrete and the rigidity of concrete to support rain gardens, all of a sudden you're covering entire hectares of urban spaces in concrete just to support a rain garden. Now we're talking about some serious carbon footprint. Add to that that you take that massive carbon footprint of the concrete in the first place, and then you cover it with stone. Your epoxy resin 80mm stone veneer right across that surface. Then now not only are you paying for the cost of the concrete, you're paying for the cost of the stone. So you're paying a double cost, double whammy cost for the rain gardens. And so what that is it demonstrates an aesthetic decision based off a performance-based decision. And it comes at a really high cost. And that's fine if it's dealing with 100% of the stormwater requirement. All right, maintenance was really counterintuitive. But maintenance from a carbon perspective is the carbon cost that keeps giving and giving and giving. And so when we realised that there was a cost, the way we build a space and the materials that go into the space, we wondered about, well, what's the cost of maintaining that space for the next several decades that that space lives, right? And what was interesting about it is we talked to the Christchurch City Council and we got an area of, we took an area of land the size of Cathedral Square. We talked to the contractor managing Cathedral Square. We said, all right, how do you manage it? What's your fuel cost? Now, Cathedral Square is washed every single day, 365 days a year. And then the equivalent area of lawn was mown 18 times a year. Right? So when you look across a stone plaza, you would think that that had the higher carbon footprint, particularly when it's maintained every single day. The grass had the higher carbon footprint, significantly higher, to the point that over the course of a decade, all of a sudden it exponentially went up. Right? And that's because there's 2.5 kgs of carbon per litre of diesel to manufacture diesel. Right? And so this has been a problem for a while, because when New Zealand first got colonised, it got colonised mainly by the English, and we adopted the English landscape system, which involves a lot of grass. And since then, we've become quite addicted to grass ever since. And so if you look at an average big town or small city, you take the area of open space that they manage, multiply it by the frequency in which they mow that grass. The average town, or the average big town or small city would be mowing over 13,000 hectares of grass every single year. Right? And that comes at a cost of about 35,000 tonnes of carbon for just mowing grass. Now, if you were to take an area of an iconic landscape like Hagley Park, to mow Hagley Park, you'd be producing about 6 tonnes of carbon every year. If you were to offset the carbon cost of mowing Hagley Park every year, you would have to plant a forest the size of Hagley Park every 25 years, just to keep the grass mowing. And when we mow grass, we don't just mow grass. We really mow grass. They had just finished mowing the grass when we walked through, and it was 15 mils long. In some cases, council will mow an area of grass, depending on the standard, 38 times in a year. So we like mowing grass. What's interesting about it is actually, grass is not the only option. So this is Harburger Park, just down the road from where I live, in Texas. Now, we don't have the luxury of high quality soil and a lot of water like you do. And so Harburger Park has, I would argue, without the rugby fields, the same amenity as Hagley Park. Right? There is a dog park, there's a playground, there is yoga, there is exercise groups, there are bike trails, there is parties all the time, big areas set up for parties, which San Antonians know how to do well. They open it up for camping. They actually camp in there a few days of the year. It's a reasonable sized park, but it has a very high amenity. There is not a square metre of grass in the whole park. So, delivers the same amenity, if not greater, than your typical New Zealand reserve, but doesn't have any grass. Now, the other thing that Texans use to avoid grass is they grow meadows, or prairie. Now, Texas used to be prairie before it all got burnt off and they started grazing it. And when they did that, the water table dropped. But before that, actually, Texas had a lot more open waterways, lakes, and rivers. They have, since Lady Bird Johnson reintroduced meadows back into Texas, the Texans will now have reserves that have meadows. And so instead of these spaces being mown, say, 18 times a year, they get mown 4 times a year. But where they plant a meadow, not only do they have a lower carbon footprint, but the groundwater starts recharging, right? So the water flowing across the ground coefficiently changes, and it goes into the ground, and it recharges the groundwater table. It really creates a much stronger ecology. So they create quite strong ecological islands where these meadows are. And they recharge the groundwater table, and they have a lower carbon footprint. And wherever you want to do the go-go, wherever you have the playground, that area is mown. But we don't need everything mown within 15 mils, and that's how they manage it. All right, so if there's a carbon footprint and a significantly higher carbon footprint to the way we build, right, then, and we pay that, we have no choice. You know, our communities need high quality open spaces, they need the plazas to meet and greet people and hang out on a hot sunny day. You have to invest in concrete and cut stone and materials. That's a cost that we should be investing in. But that cost has to stay around for a century, right? So what becomes the kicker is the urban renewal. If you pay a high cost for a public space and it gets pulled out in 20 years, then we're duplicating the cost. So let's have a look at that. So Cathedral Square, for example, has been rebuilt 3 times in a century. Now, if you accept that Cathedral Square is an important space for a range of reasons, and you are willing to pay that cost for having high quality paving and trees and seats and all the rest and lighting and art, and you pay that cost, and you've paid a carbon mortgage to that level, right? The worst thing is to then pull it out and they add to your mortgage without ever paying down the first part. Every time you do urban renewal, it steps up the carbon mortgage of that space, and that debt gets passed on to the next generation because it's impossible for this generation to pay it off. So we need public spaces to last a long time. It's just they don't. And I've been wondering about why they don't. So this is Manukau Square in Auckland. Now Manukau Square is special because it won the George Malcolm Award in 1988, and it was finished about 1988, 1987, somewhere around there. And it was considered such a significant design that the NZILA gave it New Zealand's top award. Now that top award is only given out once every 2 years to one project. And this won New Zealand's top award. And you can see the red arrow shows where the line road used to be, and they created grass areas and paved areas and put some trees in and some great places to hang out, and they took the road out. 18 years on, they rip out New Zealand's top landscape, put the road back in, put some paving in, put some grass in, put some trees in, and make a nice place for people to hang out. And you have to wonder why. And I think it's pattern making. Part of, I think, the New Zealand psyche, design psyche, is around pattern making. We're very literal in our interpretation of place, and we make patterns. And we put those patterns on the ground surface. And if you're in Taupo, it's sleeping trout. And if you're in Canterbury, it's all about the meandering rivers. And so with patterns, they're fashion driven and they date. And so what we would have celebrated in 1980 may not be so keen on in 2001. What we loved in 1990 is starting to look a bit old now. If you look around the world, and when I first started thinking about this was when I lived in Bethlehem. I said I worked in the West Bank. So I lived in Bethlehem, and it was amazing to walk on paving stones that were 1,000 years old. And it made me wonder, what did they all have in common that these incredible spaces still exist? Well, they had highly durable materials used. They were all flexible paving, which means they're easy to maintain. But there was no grand design gesture on the ground. It was simply the beauty of the natural material. There was no hibiscus flowers sandblasted into the paving or hakeki patterns. It was simple material, and the people made the life of the space. The incredible architectural edges made the life of the space. The trees made the life of the space. The street art, the street performance made the life of the space, not the pattern on the ground. These spaces not only have been around now for hundreds of years, you wouldn't dare put one of these out now. Now I know the cynics in there will be saying, well, you're right, Craig, but this is Europe and it's really old. And so yeah, of course, but you can't compare New Zealand to that. All right, fine. But tell me where our 100-year landscapes are. New Zealand's been populated for a while. We've been building urban spaces for at least 150 years. Where are our iconic, enduring landscapes? We've pulled most of them out, and we've replaced them. And on average, we replace them every 25 years. That tells me that there's something wrong with what we celebrate in this country. And I think when we pull spaces out, we're a little bit too fast to pull them out. Now, I recently took my family to Mexico City, and we were walking towards a market through a neighborhood that arguably clearly had some social issues. It was close to some government buildings. So there was barbed wire on the buildings, and what I really loved is the portable riot shields that you could move right across an entire road to block off a road. So depending on where the riot was coming from, you could pick the big shields up and block off whole blocks. It was okay if you were a cop caught on the wrong side. They built little gates into the riot shield so that you could go onto the right side. And there was this park. Now the park was simple, paved, stone. The stone was dirty, pretty grotty. It was hard to tell what the original colour of the stone was. It had quite nice trees. The amenity planting was a bit average. Street furniture, not a hell of a lot. Nothing of any real significance. And yet it was full of hundreds of people dancing. And there was no one under the age of 70 in that park. And so there was at least 3 different sound systems, and all these elderly dancing to Latin tunes, and there was lines of people sitting on plastic chairs lining up for their turn to dance. And then there was all this retail. There were people selling sequin dresses and brightly coloured shoes. It was only like 10 a.m. in the morning. There were people selling Corona beer. I mean, it was a party. And yet this park would not have won any NZILA design awards. And yet it was rocking. But I can't help but think that changing the paving, changing the seats, changing the lighting would have made no difference to that park. It was the social programming and the organisation of the dance that brought that park to its life, not what was happening on the ground. Now, social programming is not unusual, and I know that councils do employ people or do write, social programs, say like farmers markets. They organise farmers markets and, pop-up discos. What did I see the other day? I saw a pop-up spa in their public spaces. But what I would suggest is we probably don't do it enough. And we should at least, when we look at these spaces, and we were unsure and thinking about pulling them up, maybe spending a year doing some social programming into those spaces to see if you could bring life back to them before we pull them out is probably a good investment of not only the community's money, but their carbon account. So this is Brooklyn Bridge Park. Me and Liam went here recently, so these are photos from a trip we went. And I love this. I mean, not only did they have a pop-up beach with a swimming pool that they take down after 3 months, I love the fact that one of the programs was speed dating. And the little billboard before that was the beer menu. I also think that sometimes when it comes to social programming of our open spaces, we also limit our thinking to things that fit within a certain framework. The idea of retail happening in public space or alcohol consumption within public space is often frowned upon, but it certainly helps with speed dating. So I think that we should think about the social programming a little bit more before we get the bulldozers in. If you want inspiration for social programming, you want a local version rather than the New York version, then it certainly is hard to look past Gapfiller and Christchurch, where you had a whole lot of really average spaces. Some of them were just gravel, certainly no high quality materials. and the massive amount of social programming that went into those spaces. Obviously, some of the more famous ones, the Dance-O-Matic, where they had an old washing machine, pumped out music, and Prince Charles went and did a couple of swings. They had bingo, and they did also do really interesting public art trails and digital programming of these spaces. But you don't have to start from scratch, I suppose is my point. There is a ton of this stuff out there that you can copy and paste. So there is an impact to what we do. And I think that we need to slow down on our urban renewal. But we also need to generally reduce the carbon footprint of what we do because we can't offset it. And I've talked, because this has been going on for about 15 years, and of that 15 years, I spent 10 years teaching the carbon landscape to students, and so I talked to the head of school, Simon Swaffield, about this, and he said, well, the solution is education. You teach the youth, and they'll make the right decisions, and it will solve the problem. And it was an interesting point, and we did a little survey around that. We talked to all the ex-students who are about 8 years out, and we found out that actually they didn't have a lot of say yet. That they didn't have the ability to influence the design decisions or the material selections that were happening yet. And so education is powerful, but it's a good mid to long-term solution. It's not the short-term solution. So what's the short-term solution? I think the short-term solution is our free market value. Right? We know that if the market reacts to something, like they're unhappy with a shoe or a product or a clothing line or a TV program, it gets cancelled, it gets changed, or the place writes an environmental policy. So we know that people swing, that the market will follow the producers and the manufacturers will follow what the market requests and rewards. The question is, what's that value? And so back, about 8 years ago, I wrote a survey to the NZILA and asked the design industry, what's the value of the projects that you've built in 12 months? How many staff members do you have, and what percentage of that was hard landscape materials? And it was really interesting because it showed several things. The average turned out, per landscape architect, the average value of a landscape architect was $677,000. Now, that's a lot of money, as an average. That's a lot of money. And so what would happen is we would get some landscape architects write to us and say, well, I mainly do visual assessment. I'd be lucky to specify $50,000 worth of materials a year. But there were big companies that were specifying tens of millions of dollars worth of materials a year, which brought the average up to that 677,000. So that's where we get the average from. Now, if you multiply that by the current industry, that gives us a market value of $400 million. Right? Now, if at the time, 53% of that budget was being spent on hard landscape materials. That means the hard landscape material market is $214 million worth of hard landscape material market. Is it a lot? Well, it's bigger than the GDP of the Falkland Islands. All right? So I'd like to think that there's some Falklanders out there who would say it's a decent amount of money. But there are two things with this. One is that it shows the value of us as we work as a collective versus an individual. I can go to anyone as an individual within the material industry and say, look, I really need help. I want to reduce my carbon footprint. Can you supply me a low carbon concrete option? And they might say, yes, I've already got it, or no. Why would I? Because you're one single person, one single designer, one single specifier. But as a collective, we have a lot higher negotiating power. But we have to act as a collective for that to be useful. Now, when you get a natural event, like we had in Christchurch, then that was one of the single biggest opportunities for us to reset the material market to give us access to lower embodied energy material. We had the budget to reward the material providing industry to supply us lower carbon materials. But instead we focused on culture and water. Now, we could have added carbon in there. They're not mutually exclusive ideas. It could have been like the next step, but it didn't. Now, even so, we've missed that opportunity. Councils still have a reasonably sizable annual CapEx budget that if they started acting as environmentally concerned consumers, still have a fair amount to say in this market. And the say should be about rewarding the companies that are supplying us positive environmentally profiled materials, the companies that are providing us low carbon footprint of materials. So we should be rewarding those companies, we should be celebrating those companies, we should be identifying those companies. And the ones that aren't supplying those materials to us, or are not supplying the transparent information for us to even make informed decisions on environmental materials, we should be having conversations with them. But we need to do it as a collective. We need to move from an appearance-based design approach to a performance-based design approach if we want to deal with climate change. So, if I was to outline steps moving forward, the first thing I would say is we have to acknowledge that there's a problem. As soon as we acknowledge that there is a carbon footprint to what we do as an industry, the value of that is that it stimulates the academics to research. But until you identify the issue, then there isn't the academic research being done on that issue. And so if we want to move forward, we need to work as an entire community, from the academics all the way through to the design industry. And so acknowledgement's a very important first step. And then we need to focus working with our material partners to get access to low embodied energy materials, so that when we do those public spaces, they are as low as we can possibly get them from an embodied energy perspective. And to get that, I think the best way to do that is to start financially rewarding the people that can supply those materials with our collective market value. We need to create specifications around how we implement projects from a carbon landscape perspective. So how do we build a project in the most carbon efficient way? And the only way I think to do that is really for the council and the clients, so the clients being the councils generally at the top of the food chain, to start requiring the consultants and further down the track the tenders, whoever wins the tenders, to start recording the way they build projects. So we can start understanding where the carbon sits within those projects, so we can start working out where we can reduce and manage those costs. We need to do the same for the way we manage and maintain land. We need to, again, work as a collective to work out how we maintain and manage lawn, amenity beds, trees, paving, it doesn't matter which one, but how do we manage it to meet the community's expectation of quality, as well as the next generation's requirement for a lower embodied energy and a livable climate. And finally, I think we really need to slow down the rate of urban renewal, or at least test out some ideas before we bulldoze our public spaces. I think part of the way to reduce the rate of urban renewal beyond social programming is that when you design new spaces, when you put the design tender out to the design industry to say, we want to design for this space, have a requirement for peer review and community review of that design. Within the industry, designers normally sit at a reasonably high position, and there may be some initial public consultation early on, but there really isn't a very strong feedback loop into the design and how the design is going to be built. And I think that often the reason these designs fail, and fail the community, is the lack of checks and balances in the design process itself. Now, that's not a very popular idea within the design community. No designer wants to be told that their work should be peer reviewed. But for the sake of the next generation, it makes some sense. So if I was to leave you with a parting thought, I suppose I would suggest that to not consider the climate and the carbon impact of our work is intergenerational theft. We're taking away the resources for the next generation to enjoy the same quality environment and quality of life that we enjoy today. That's the impact of the decisions, which means that we need to move away from ego-driven design, much more towards an intergenerational design process and management process. I think that's the point that we were at. Thank you very much.